Okay, so we're going to be continuing on with the chapter 2 packet. We're going to be doing notes on page 29. You do have homework tonight on page 28. I don't think we're going to get through all of the notes on page 29 though. So page 29 looks like this. This is a topographic map. It actually is just like the maps we were just drawing in class. It's one of those, just with a little more detail on it. So a topographic map, so if you guys could follow along and put notes right where I am. So a topographic map is another name for a contour map. So those are kind of used interchangeably. Contour map, topographic map. And again, what does a topographic map or actually a contour map show you? It's a map of what? Of what? Mountains, elevation. So these are maps that show elevation. Well, sorry, that got messy. Maps that show elevation. So for this year, the first thing you have to be able to do is draw one of these. So like you are doing for homework, like we just went over. You're given a bunch of numbers and you need to be able to connect the dots. The second thing you need to be able to do is read one of these maps. So if you're given one, you need to be able to decide what does it mean? So to start off with, we're going to just do a few vocab words with these maps. The first vocab word is a map scale. That should not be anything new. First of all, what's a map? Where is the map scale? On the bottom, right here. If you did not know that off the top of your head, please label this map scale. So what do we use a map scale for? Yes, I couldn't put it better myself, Cynthia. A map scale is used to determine distance from one place to another. So map scale is used to determine distance between one place and another. For example, and you don't have to add this, well, if I had X here and Y here, you would use the map scale to determine how far apart they are. Like if you had to walk from X to Y, how many kilometers would you be walking? So that's what a map scale is used for. Contour interval. What? Those are the lines. The contour lines are the lines that show elevation. So the contour interval is what the lines go up by. Or what they count by. Now, sometimes they'll flat out tell you the contour interval is 10 meters. Or sometimes they'll give you a hint. For example, go ahead and label this. What if this outside one was labeled 0? And what if, hang on, let me double check. I'm trying to do this from memory. What if this line right here was labeled 100? So that this first one in here. So what if they labeled just those parts, 0 and 100? How do you figure out what the rest of the lines are going up by? Okay, Cole knows how to do the math. He is correct. He will get the right answer. You guys should know by now, I don't like doing math. So what I do is I just try some numbers. Just like with the labeling of the graphs. I try some things to see if they work. So if 0 and 100 are labeled, are they going up by ones? Not even close. Twos? 0, 2, 4, 6, 8, 10. Does that get me to 100? It does. Huh? You could do 20s. Before that, probably would have had to try a few more. Maybe 10s, 10, 20, 30, 40, 50. You're right there by 20s. And you can go ahead and label that 20, 40, 60, 80, 100, and then 120 is in the middle there. So sometimes they're not going to label all the lines and you have to figure out what's missing. And by the way, they're always going to be different. So this map went by 20s. The next map we look at might be 10s. Sometimes they do go up by 1s, depending on the map. So it's always important you double check to see what they're going up by. So again, the contour line is what the lines go up by. Now, direction of a stream flow. This thing here is a river, in case you didn't know. And I'm going to get rid of that arrow at the top because they're never going to give you the arrow. So I'm just going to make this river wider so that you couldn't see the arrow at the top. So I already gave it away. This river is flowing from here to here. But if I hadn't given it away, what do we know about rivers? Rivers always flow downhill. We're going to have to put a couple of bullets here, so don't write huge. So direction of stream flow. Streams always flow downhill, which is luckily for us, this map shows elevation. So this map shows us which way downhill is. How can I figure out which way is downhill? There's no labels up here. What line it's on? Remember, this line right here, this 0 one that's labeled here, is not only 0 here, but 0 everywhere on this map. So up here is 0. This one right here, if I follow the beginning of it around, gets me to the 80. So the stream will always go from the highest elevation. I'm going to add that in case they go from highest elevation to lower elevation. They always go from up high to down low. Sorry. Streams always flow downhill, highest elevation to lower elevation. But there's another way, another trick for these maps. What time do we get out? 41? Awesome. We got plenty of time. So the other trick for these maps, and I have to take you on a little memory field trip to do this. Ready to go on like a little brain field trip? All right, who needs Tim Hortons? Yeah, sign me up. I like black coffee, everyone, in case you ever need to know that. No cream, no sugar, black coffee. It'll always get you brownie points. Just saying. Okay, is anyone acknowledging that I'm trying? Okay. Okay. All right, just saying. Birthday's April 5th, like black coffee, Christmas, Thanksgiving, Tuesdays, whenever. All right, anyway. Going to Tim Hortons. We have to go to, not the one over by Tops, though. We got to go to the one over on 16. It has a shorter line. I don't know. We're going there. So we're going over on this field trip. And can you guys picture yourself driving there or being a passenger since you guys aren't old enough to drive? What do we pass before we get to Tim Hortons? Plus Boys. So I guess we're gonna put Plus Boys over here. Huh? Yeah, but I meant Plus Boys. He's right. But yes, the stores. But I really want to talk about Plus Boys. Plus Boys is here. Then what? A what? A big bridge with a big bridge. Then we finally get to Tim Hortons, right? Timmy Hose. I don't know if that's how you spell Timmy Hose. It's not, is it? Timmy Hose with just an S. Timmy Hose over here. Eli already gave it away. What's underneath the bridge? There's a creek. And how, if you were to walk on that creek to the creek, what would you have to do to get to the creek? You go downhill. Underneath the bridge, kind of looks like this situation. I'm over exaggerating it, under exaggerating, whatever. You gotta go downhill. Picture, so that's our virtual field trip, by the way. We're not actually going to Timmy Ho's. We're just talking about the creek. I just wanted you to picture this. The creek goes down, but. What? Okay. Do you need some Tim Hortons? You don't want any Tim Hortons? Okay, what I also have to agree, it's not my favorite coffee. I'm very looking forward to the new coffee shop opening in Arcade. Anybody else? 49 something or another. Very excited. Very, very excited. Anyway. You want to come, Ellis? I think you're out of luck. Dude, we're just speaking coffee. Coffee is way more important. Oh, okay. All right. Anyway, you'll understand in a few years. All right. Anyway, off topic. Can you picture yourself going to any creek, any river, any little drainage system? To get to any creek, what do you have to do? You gotta go down a little. Every little creek, Kless Boys is pretty, or the one between Kless Boys and Tim Hortons, that's pretty significant. It's a pretty downhill. It's not as big as they can be, like over on that 219, the 219 bridge. That part of the creek goes down way low. But anyway, any little creek you've ever been to, even if it's just the one in your backyard, you still go down a little. Every single creek goes downhill. So what does that do to the contour map? Is it messes with the contour lines. See how this was going? It could have just gone nice and straight across this, what line is this? The 20 line? It could have looped right across just like that 0 did. But the creek or the river, whatever this thing is, messed with the elevation. So it causes that dip. See how every single time the river crosses, it kind of causes like a dip in the contour line? See this? You see what I'm talking about here? And here? And here? The contour lines are going to bend every time it crosses a stream. And there is a trick. See how they kind of make, that's like a U or almost even a V shape, the bend? The creeks will always come out of the bend. So water will always flow out of that, whatever shape you want to call this. So the water will always flow out of them. So I want to add that bullet. Contour lines always point upstream, which means water flows out of the bend. The contour lines always point upstream, which means the water always flows out of the bend. Again, did everybody get that? Water always flows out of the bend. So if this is the bend, water is always going to flow out of that bend. All right. If this is the bend right there, the water is going to come out of the bend. Every single time a stream crosses a contour line, that's what it's going to look like. I'm going to show you a couple examples in the back here. You don't have to flip back. I'm just going to show them on the screen if I can find one. Yeah, here's a map we're going to do later this week. Here is, what does this say? This says Colden Creek right here. So this is a creek right here. Every single time, here's a contour line, here's a contour line, here's a contour line. So they point upstream, meaning they point to where it came from, and the water is going to flow out of the V. So if this is the bend, they're going to point, the water is going to be going this way. The water will always come out of the openings. So what does this have to do with anything? So the Regents is going to ask you a couple of, so one question they could ask, what is the general compass direction in which Maple Stream is flowing? So again, here's Maple Stream. There's the V, or there's the bend, the water is going to come out of them. So it's going south. So that's one thing they could ask. Or another question is, how do you know which way it's going? And the way you know is by the bends in the contour lines. They always bend and the water will come out of the bend. All right, we have time for one more bullet, I think. And that's talking about the steepness. Sorry, I lost my page. The steepness of a hill. The steepest section of a map. Guys, what do I mean by steep? Everybody's got it with charades. Show me what a steep hill looks like. All right, so a steep hill, let's say we're going up a mountain. You guys got lots of my drawings here today. You're going up a mountain. Here's the base of the mountain. This is a pretty steep climb. It's hard to climb. Versus what would a gentle slope be? Not hard, it's the opposite. It's the bunny hill if you were skiing. So this one is a more gentle slope. Very steep, gentle. So just in case, steep, gentle. In case you did not know, the opposite of steep is gentle. Do both, if you were to walk up either side of these, do you get to the same height? Yeah, if you get up here, you're up there, no matter which side of the mountain and you guys don't need to be drawing this, by the way. As long as you get to the top of the mountain, you have climbed, let's say that's 100 feet high. What's the difference though? One's easier, one's harder. But the easy one, what's the difference on that easy one? You're still going 100. It's longer. If you were to be tracking how many miles or how many feet or probably miles you're walking, this one is longer. It's a longer distance. To get from the bottom to the top, you're walking more steps. The distance is greater here. So it takes you a longer distance to get that height. Here, you only have to go from here to here, and it's changed. You get to the top of the mountain. Taking less steps, yes, it's going to be harder to walk, but you're taking less steps. You're going a shorter distance. So how does that look on one of these? So here's a map. Let me actually pull up the map we've been working on. Same map, just different packet. So we're looking here, which side of this is going to be steeper? The left. How can you tell that this side, the left, is steeper? It's a shorter distance. What else can you tell? So what did you mean by this? It's squished, is that what you said? That's exactly it. So either way you look at it, it's shorter or they're squished. The lines. To go up this side, here's 0, 20, 40, 60, 80, 100, 120 feet. In this short distance, you're going 120 feet. On this side, you have to walk this far just to get to 20. Even further just to get to 40, 60, 80. It's a longer walk on this side. Yes, you're eventually going to get to the same height, but it takes longer to do that. So for the steepest section, first of all, what I want you to do is break this box into half. Because we're going to do one side for steep and one side for gentle. The steepest section, what you need to know is this is where, so where contour lines are closest together. And the gentle section is where contour lines are far apart. So one thing you will have to be able to do is look at a map and say, this side is steeper than that side. On that note, this is as far as any other class has gotten, so trying to keep everybody together. We're gonna stop there, but you do have about 5-6 minutes. You have homework, which again is page 28. I highly recommend getting at least one line drawn. We've already established the first line you're gonna draw is 70. So go ahead and attempt that map. If you want a highlighter, they're up here.